Today we'd like to go a little farther with our moving sources of waves. So in the last video, we saw how when an object was at rest, everything was symmetrical. So if we have an object giving off sound or light and the object is at rest, in all directions we will get the exact same wavelength and frequency. It may get less loud or less bright as you get farther out, but everybody should pick up the exact same frequency. We then looked at an object traveling while giving off sound or light. And we saw how the waves would get smushed in one direction, the direction it was moving, and spread out in the other direction, the direction it was receding from. We saw we'd have a higher frequency on the one side and a lower frequency on the other. The high frequency side also had a small wavelength, and the low frequency side had a bigger wavelength. Today we'd like to have our object move a little bit faster. And here you can see the object traveling exactly at the speed of the waves. So the airplane is traveling at the speed of sound. And we saw that when we did that, we had our object and our waves overlapping. And if you could draw this out, you can see all the waves are overlapping at the front of the plane. This is going to create an area of tremendous turbulence where we get high and low pressure regions right on top of each other. Okay, so we're going to create high turbulence. The first person to ever break through this turbulence, and this turbulence is sometimes referred to as the sound barrier, was a person named Chuck Yeager. You can see Yeager was from America, from West Virginia to be specific. And you can see he lived from 1923 until quite recently. He broke through the sound barrier on October 14th, 1947. First person to travel faster than the speed of sound. Sometimes when you're talking about speeds that are close to or above the speed of sound, they'll refer to them by what's called a Mach number. So if you're traveling at the speed of sound, you are at Mach 1. If you're at Mach 0.5, you're at half the speed of sound. And if you're at Mach 2, you're going double the speed of sound. There's also some names for these. So if you're below Mach 1, it's often referred to as subsonic. Transonic is when you're right around the speed of sound and you're experiencing all that turbulence. Supersonic is when you're traveling faster than the speed of sound. If you're going really fast, 5 times or more the speed of sound, it's sometimes referred to as hypersonic. All right? The real transition, though, is going from subsonic to sonic. From having the waves in front of you to having the waves behind you. So here's an object going supersonic, and you can see how it leaves the waves behind. You can see how the waves build up. Oops. We can see how the waves build up in certain locations. Clear that out. Those are going to be regions of very high pressure. And if we trace them back from the plane, you'll see that those areas of high pressure form a cone behind the fast-moving object. That cone of high pressure produces what's known as a sonic boom when that cone of high pressure passes by you. All right, so at supersonic speeds, you're going to have a cone of high pressure, and when that cone of high pressure hits you, it's called a sonic boom. Think of the cone of high pressure a lot like the wake that follows behind the boat, where all the waves overlap to form a really large wave. Sometimes you'll have condensation happen in these high pressure zones, and you can actually see the cone of pressure following behind the plane. All right, so you now know what things are going to look like when you're traveling supersonic or when you're traveling sonic. And we already talked about when you're traveling subsonic and you experience the Doppler effect.